All right, this will be our homework help video for logarithms as inverses and graphing logarithms. Let me just make sure you can see this. Doesn't look like you can. That looks right. Okay, getting started. So this will be our answer key. The directions for the first four tell us, well, for the first 8, tell us to find the inverse of each function. The first 4 are all given in exponential form. The steps, regardless, when it says find the inverse, I'm given an algebraic equation. The first step is always to just swap the x and the y. All right, if the intent of the inverse is to take in any output of the first function and then give you its related input, then by swapping x and y, it's guaranteed to do that every time. So now I've got x equals 10 to the y plus 9. After I swap them, now at this point, it's all about just isolating your y variable. First thing I'm going to do is isolate the term with the exponents. I'll do that by subtracting 9 from both sides. Now I've got x minus 9 equals 10 to the power of y. This here needs to now be rearranged into a logarithm. So it's log, the base of the exponent becomes the base of the log. Then the value on the other side becomes the argument. And then the y is left, that's all alone. So you can double check this with the swoop. 10 to the y equals x minus 9. That is that equation there. So we're done. We have found the inverse. It is this function here. Let's try number 2. First thing I'm going to do is I'm going to swap that x and that y. X equals 5 y over 3. Now I've got to isolate y. There's no operations outside of this exponent, so I need to go immediately into rearranging into a logarithm. So I just write the word log, and then I start going through the process of taking these 3 elements and putting them in the right spots. So the base of the exponent becomes the base of the log. The number on the other side becomes the argument. And then the y divided by 3 is now what's isolated. But I haven't totally isolated y yet. I need to multiply both sides by 3 in order to do that. So now I've got 3 log base 5 of x equals y. That is my final answer right there. Let's double check that this looks like it is streaming. Does. All right, let's do a couple of these where we start with the logarithm. We'll do number 6. Number 6 looks a little bit interesting. One thing I noticed is that there's no base here. So the default base when there's no base is a 10. First thing we want to do is swap the x and the y. So I've got x equals log base 10 of y minus 2. There's no operations outside of this logarithm, so our next step is to do the rearrangement. Base of the logarithm becomes the base of the exponent, so 10. We could do like a swoop here to help us remember the order. 10 to the power of x now equals y minus 2. Add 2 to both sides, and I've got y equals 10 to the x plus 2. That is for number 6. For number 7, go ahead and swap x and y. Change colors here. X equals log base 6 of y plus 3. First thing, now we do have an operation outside of our logarithm, so I'm going to subtract 3 from both sides to get that x minus 3 equals log base 6 of y. Now we're ready to do the rearrangement. Base of the logarithm becomes the base of the exponent, 6 to the power of x minus 3 equals y. So to help out or to double check, you could do the swoop. 6 to the power of x minus 3 equals y. That's exactly what we wrote down here. All right, so those are the inverses of our functions. Identify the domain and range of each. All right, so the domain, quick way to do this is just take the argument and say that 2x minus 1 must be greater than 0. We cannot take the logarithm of a 0 or a negative number. It just doesn't make sense. These logarithms ask the question, this number, which is the base, 2 to the power of what equals the argument? Now, if you've got a negative argument, there's no number, positive or negative, I could raise 2 to the power of to reach that number. From here, I'm just going to keep solving, add 1 to both sides. Now I've got 2x must be greater than 1, divide by 2, divide by 2. X must be greater than 1/2. That right there is the domain. The range is the same for all logarithmic graphs. They reach up and down to positive and negative infinity, so it's all real numbers. We show that with the double stroke R, just like that. If it was an exponential graph, the domain and range are going to be swapped. The range will be limited by the horizontal asymptote. If I can remember, I'll try to do a problem like that later on in this worksheet. So let's see, number 11. I think I rearranged this. The instructions here for number 11 should be the same as the backside. If you just graph it, it's fine, but what I was hoping is that you would sketch a graph of the function, then find the inverse of the function and graph that as well. So the directions got a little out of order there. If you just graph the function, that's fine, but let's find the inverse. And in fact, to graph this function, finding an inverse is a good first step because this can be kind of difficult to graph, but exponential graphs are a little bit easier, and then we can just invert all of the points. So to find the inverse, we're going to swap x and y. Do that down here below the graph. X equals log base 4 of y plus 2 minus 5. Add 5 to both sides. X plus 5 equals log base 4 of y plus 2. We will rearrange this into an exponent, so 4 to the power of x plus 5 equals y plus 2. Subtract 2 from both sides. So now we get our final exponential graph, y equals 4 to the x plus 5 all minus 2. All right, so there are two shifts happening here. This plus 5 being done directly to our variable is going to shift us left 5, and this minus 2 is going to shift us down 2. That's just for the exponential graph. Then we'll have to invert all of those points to get our other graph. So let's graph. The very first thing we're going to graph is just y equals 4 to the x. All right, so this sort of the parent function for this graph. This should have a starting value of 1, and then it should go up 4 times as high each time. The next one would be 16. That's off the graph. And then these points flatten out to 0 pretty quickly. All right, now I want to shift each one of those points left 5 and then down 2. So if I move left 5, 1, 2, 3, 4, 5, and then down 2, right about there, 1, 2, 3, 4, 5, down 2. It's about there. And this trails off to a horizontal asymptote of y equals -2. Now that I have those points, let's invert each of their coordinates to flip them over this line. Actually, if I can draw that a little thinner. Okay, our 45-degree angle line. So I'm dealing with these red dots here. This dot, first one here is at -4, 2. So the point 2, -4 should be in the inverse. Orange. This point here is at -5, -1. So -1, -5 should be in the inverse. Then these points here, -6, -1.5, so -1.5, -6. And it's going to trail off down here. All right, so here is our actual logarithmic graph. Goes up like that, and let's add in a dotted line for its vertical asymptote. Right there, let me do a different color to green. There's the vertical asymptote for this graph, located at x equals -2. Let's see if that looks right. Number 11. Yep, vertical asymptote at x equals -2, going up and to the right. Obviously, you can use your calculator to help you graph these, but it's a pretty good exercise to practice going through the inverse, doing manipulations on a parent function, and then inverting those over this 45-degree angle line to get our final graph. Let's skip 12. We'll go to number 13, practice that same process. So I need to first find the inverse of this. So I'll have x equals log base 6 of y plus 5 minus 1. Swapping the x and the y. Now solving for y, I can add 1 to both sides. I've got x plus 1, so log base 6, y plus 5. And rearrange this, make it 6 to the power of x plus 1 equals y plus 5, minus 5 from both sides. And I get 6 to the x plus 1 minus 5 equals y. So this has got two transformations. That minus 5 is going to move us down 5. And that plus 1 will move us left 1. It's kind of always the opposite of what you think. So let's just dot in 6 to the x. It's going to go 1, 6, and then be off the graph. Let's move those 2 points left 1 and down 5. So left 1, down 5. Maybe we'll switch colors. Left 1, down 5. Left 1, down 5. And now let's flip those points over our 45-degree angle line. So the point 0, 1 is going to become 1, 0. -1, -5 becomes -5, -1. And then this graph, which used to have the inverse, has got a horizontal asymptote at y equals -6. Now the inverse is going to have a vertical asymptote at x equals -6. So here's our final graph. Coming in from -6. It's these 2 points and then goes off the graph. All right, and that has got a vertical asymptote at y equals -6. Shouldn't be -5. I think I got 1 unit off here. Let's see, yep. That's -5, it moved down 5. Yep, that point was 1 too high, so I'm just off by a unit here. Let's do it again real quick. Okay. 6 to the x. That gives me a point at 0 and 6. Those move down 5, left 1, so that gives me that point there. Down 5, left 1. Yep. Flip those over my x-axis, so that point there, that point there, and then a horizontal vertical asymptote at 5. All right, looks pretty good. Add in a dotted line for that vertical asymptote, or VA for short. Let me check that one as well. Yep, looks about right. We'll do one of our last ones here. Here we've got the starting with exponential form. We'll go ahead and just graph this, then we'll find its inverse, and then we'll invert the points to graph that as well. So this has got a starting value of 1/4. Maybe this one would be useful to make a table for. So at x equals 0, I am 1/4 of a unit tall. But each time I move forward 1, I'm going to triple in height. So by the time I'm up to x equals 1, triple this is going to be 3/4. Up to 2, this triples again, it's going to be 9/4. Up to 3, that triples again, that's going to be 27/4. And that by this one, we're up to 81/4. And I'll give a decimal approximation for these. So 0.25, 0.75, 2.25, 27 divided by 4, 6.75, and 81 divided by 4, 20.25. All right, so we'll do our best to plot those. We got 1/4 up to 3/4, 2 1/4, 6 3/4. By the time to 4, we're just off the graph, so right about there. All right, and then on this side, it's approaches its horizontal asymptote very quickly. So there's a graph of our function. Do a better job connecting these dots. Here we go. Nice flat line. Then it grows very quickly. All right. So that is this function here. Now it's time to find the inverse and then graph that. So y equals 1/4 times 3 to the x. I'm going to swap x and y. So x and y are going to swap spots. This is going to become x equals 1/4 times 3 to the y. All right, to get rid of that 1/4, I'm going to multiply both sides by 4. Get 4x equals 3 to the power of y. Rearrange this into a logarithm. So log base 3 of 4x equals y. There's our inverse. But to graph it, I'm just going to reflect all of these points the best I can. So this should be now 1/4, 0. So right there. Then we should have 3/4, 1. 9/4, 2.5, so just about there. 27/4 or 6.75, comma 3, and we're off the graph. So there is our inverse, f to the negative 1 of x. And you can see how that is symmetrical over a 45-degree angle line. It just goes off the graph pretty quickly. This side here is going to extend down to negative infinity. All right, and we've graphed that. Best of luck finishing up this homework. I will see you in class.